In today's video, we are going to evaluate integral minus infinity to plus infinity sine e power x dx. Here the function is sine e power x. If you consider e power x as u, then du it becomes e power x dx, isn't it? So from here you can find out dx. So the dx, the value is du over e power x. Already we consider e power x as u, so that's why dx equal to du over u. Substitute in our expression. Here we have integral sine e power x. Instead of e power x we consider as u, so just take u, and dx is nothing but we are converting in terms of u, that's why. So we have 1 over u du. And now observe the limits. The lower limit is minus infinity. That means if you consider x as minus infinity, then you will take e power minus infinity. That means you are taking e raised to power to a very large negative number. The result is approaching to 0, isn't it? So that's why e power minus infinity, the value is 0. This is the lower limit. That means your lower limit converts into 0. If you take upper limit, that is x as plus infinity, so let's take in terms of e power plus infinity. So that means you are taking e raised to the very large positive number. So very large positive number is it is approaching to infinity, that's why upper limit it turns into infinity. Now we have to solve this integral 0 to infinity sine u times 1 over u du. We are going to use integration by parts. Before that, let's observe this 1 over u. If you take instead of 1 over u as integral 0 to infinity e power minus ut dt, that means you are doing with respect to t. Here u is a constant. For this e power minus ut minus 1 over u e power minus u. So let's apply the upper and lower limits. This is a constant. First take it constant, then apply the limits. E power minus infinity minus e power minus 0. We know that e power minus infinity, that means we are taking e raised to power of very large negative number. That means it approaches to 0. So this value is 0. So let's take 0 here. The value is 1. So minus 1 over u, 0 minus 1. So if we expand this minus term minus which gives plus, so then 1 times 1 is 1 over u. 1 over u is same as here 1 over u. That means instead of 1 over u, we can take integral of 0 to infinity e power minus ut dt, isn't it? So I am going to take that. Instead of 1 over u, I am going to take integral 0 to infinity e power minus ut dt. Still we have du. So we have integral 0 to infinity and here integral 0 to infinity. That means we have double integral. So let's take it as 0 to infinity and the second integral 0 to infinity, and we have sine u e power minus ut dt du. Let's take only one integral, that is 0 to infinity sine u e power minus u. This is in terms of u, that's why we have to take in terms of du, and the dt you just keep it here. Now take this inside part. This considered as equation 1. Integral 0 to infinity sine u e power minus ut du. So we are taking only this inside function. Consider this as I. Now use integral by parts. Let's consider this u as e power minus ut. Here already in terms of u, that's why you just consider this as to introduce new variables, that is x and y. Here if you consider x as e power minus ut, then if you do derivative of x, then it becomes minus t e power minus ut du. So this is our x. So we are done with e power minus ut. Still you have integral sine u du. This you consider as integral dy. That means y equal to minus cos u, isn't it? So now we know dx value, Now you know dy value and you know y and x. Let's substitute in this formula. So in our given expression, it is in the form of x integral dy, isn't it? So if you write in terms of this, then we have integral x integral dy, that is equal to xy minus y times integral dx. Now substitute this x, all these values here. So this x integral dy is nothing but this I, isn't it? So let's take this as I equal to x is nothing but e power minus ut and y is nothing but minus cos u, and limits are 0 to infinity. We have done this, that's why I am applying limits here. Minus y is nothing but minus cos u, then integral dx is nothing but minus t e power minus ut du. Still you need to do this part because we have integral here, we are not done this, that's why here limits are 0 to infinity. And observe this, minus times minus, which is plus, again we have here minus, so overall it comes minus only. So here we have t as constant, so let's take it t as front side, so then you will get t times cos u integral 0 to infinity e power minus ut du. So now apply the limits for this first one. First you have to apply the upper limit, so minus e power minus infinity, e power minus infinity, the value it becomes 0, so upper limit is going to be 0 minus, now we have to observe the lower limit, so e power minus 0 is nothing but 1 only, so let's take only 1 times cos 0, the value is 1 only, so 1 times 1 is 1, so minus term minus, which is plus, so that's why we are getting plus 1, minus, still we have integral 0 to infinity cos u e power minus ut du. So again we are doing the same thing as like this. Here we have 0 to infinity sin u e power minus ut du. Again I am considering this as I. Now this also same like in the form of xy. Now our given expression, it is in the form of x times integral dy, isn't it? So you have to write in terms of that x integral dy, that is equal to xy minus y times integral dx. Here we are considering e power minus ut as x. Then if you do derivative of dx, then you will get minus t e power minus ut du. That is our dx. So we are done with this e power minus ut. Now we have to take integral cos u du. You consider this as integral dy. So then y is sin u. Now we know y, x, dx and dy. Now substituting this LHS we consider as I, isn't it? So let's take in I, that is equal to, our x is e power minus ut, then our y is sin u. So we are done with this part, so that's why let's apply the limits 0 to infinity. Minus y is nothing but sin u and integral of dx, that means integral of minus t e power minus ut du. If you apply this limits here, e power minus infinity, the value is 0, so let's take it upper limit as 0, minus e power minus 0, the value is 1, times sin u, that means sin 0, the value is 0, so the first term it becomes 0 only. This t you take it as front, then it becomes minus term minus, which gives plus, so t integral 0 to infinity sin u e power minus ut du. After solving this integral 0 to infinity cos u e power minus ut du, we got this t times this integral 0 to infinity and this all this. So it is same as I. So we can write this t times I. So instead of this integral sin u, we can write this as ti. So here already we have t. So let's take t times. Now instead of integral 0 to infinity cos u e power minus ut du, we can write this as ti, isn't it? So this become 1 minus t power 2i. I plus t power 2i, that is equal to 1. So then I, if you take common, then you will get 1 plus t power 2, that is equal to 1. So then I equal to 1 over 1 plus t power 2. Let's go back to the first equation. So we are done with the inside term, isn't it? The value is 1 over 1 plus t power 2. So the inside part we are done, that is 1 over 1 plus t power 2. This integral 1 over 1 plus t power 2 dt, the formula is tan inverse of t. Tan inverse of t, the limits, now we are going to apply the limits 0 to infinity. So the upper limit is tan inverse of infinity minus lower limit tan inverse of 0. Tan inverse of 0 is nothing but 0 only. Let's take 0. And tan inverse of infinity, the value is pi by 2. So integral of minus infinity to infinity is sine e power x dx. The value is pi over 2.